And we're going to solve problem number 45 from the book. So in this problem, we have 4 charges that are arranged in kind of a square, symmetrically. So we have one charge, we'll call that QA. We have another charge, QB. We have another charge, QC. And a fourth charge, QD. They tell us some information about these charges. They tell us QA and QB are both equal to each other, and they're both 7.5 microcoulombs. So this charge is 7.5 microcoulombs, and this one is 7.5 microcoulombs. And they also tell us the QC and QD are equal to each other, and those are both negative 7.5 microcoulombs. Now we're going to take another charge and we're going to put it in the exact middle of this square. They also tell us that the size of this square, I believe, is 10 centimeters. So that's 10 centimeters. And we put another charge right in the middle. We'll call that Q. And we're going to say that that charge is equal to 2 microcoulombs. And I'm going to briefly erase this so that I can move where I wrote it. And put it right here. Q equals 2 microcoulombs. Okay, everybody remember this problem? You've all done this problem? How many of you got this?
Like in part A.
I kind of got part of it. Okay.
Part B is where it stopped.
So let's look at this. Let's figure out part A and part B. Part A asks us, I believe, what direction does the total force go? So what we have here is we have 4 different pairs of charges. We have QA is going to act on Q and push it a certain direction. QB is going to pull charge Q. QC is going to pull charge Q, and QD. They're all going to pull on this charge. Okay? So what we can do is we can draw vectors to represent all of those. So that's what I'm going to do. I'm going to draw some vectors. I'm going to start with, I'm going to do it in green, and I'm going to do QA. So if I look at charge QA, where is charge Q going to go because of charge QA? Some things to remember. The electric force always acts on a line between those 2 charges. So we can draw a line between those 2. So that means that charge Q is either going to go towards charge A or away from charge A. Where's it going to go? Towards it or away from it? Away? Why? Positive, so what? Goes away from the positive. Like charges repel. So charge Q is going to go down, kind of to the right. So there's our force. We'll call that force from charge A, FA. No? We have charge B. Charge B is positive, charge Q is positive, so where is charge Q going to go due to charge B? Away from it as well, so it's going to go down, right? Something else to notice about this, the magnitudes of these charges are the same, right? The distance of these charges from each other is the same. QA to Q is the same as QB to Q. Right? We know that force due to these 2 charges, what equation describes the force between these 2? Any 2 pairs of charges. Say it louder. There's a air conditioner or heater right here, so I can't hear a damn thing anybody says. And that's recorded now, so that's going on YouTube. F equals K. Absolute value of Q1 times Q2 over R squared. Okay? So that's the force. Yeah? Okay. The force depends on K, the multiplication of the product of the 2 charges. and the distance between them squared. Well, these two charges have the same magnitude as these two charges, and they're the same distance, so the force due to A is going to be equal to the force due to charge B. Okay? These are the same magnitude. So if these are the same magnitude, then their components are going to be the same magnitudes. To get to this force B, it's acting at an angle. To figure out the components, I need to figure out how much is in the x and how much is in the y. So I go to the left and then down. Same thing with force A, except I go to the right and down. So what's going to happen with the x directions for both of these forces? One of them's going to the left, the other one is going to the right. They're the same magnitude, so what happens? They cancel out. So what's the total force due to FB and FA? Where is it going to go? It's going to go entirely down. Okay? So that's FAB. We still have two more pairs of charges, so let's figure out what's going on with those. Where is charge Q going to go due to charge C? Charge C is negative. Is it going to go towards it, or is it going to go away from it? Towards it, because they're opposite signs, so force of C is going to go directly towards C. Force C. Right down there. And we can use the same reasoning for force D. Yeah? Okay. What's going to happen with the x components of each of these? Same as it did in the x components of A and B, the x components are going to cancel out. FCX goes left, FDX goes to the right, they're going to cancel. So the x direction cancels, and we end up with the force just going down. FC and FD. And really, if we want to be explicit with all of this, we need to use some profanity. No. Bad jokes, bad jokes. So we have FC, we have some force in the D direction, and these are all Y direction forces. So we have an FCY, an FAY, and we have an FBY. Right? Each one of these charges creates its own force going down in the Y direction. So we have 4 of those. Does that make sense? Yeah. So now we need to figure out that the force goes down. So part A. Force is down. Part B asks us to calculate the magnitude of the force on the charge. So now we have to figure out how big this force is. Yeah. I have 4 different charges. I know the force due to all 4 of those charges is the same. So if I figure out one of them, I can multiply that by 4 and get all of them. Yeah? So we're using some physics, using some symmetry. I know that I only want the y direction of the force, not the total force. The equation I can use force equals K times Q1 times Q2 over R squared. That'll give me that total force. I can pick any of them. Which one do you want to calculate? FA, FD, FC, FB. Which one? FA? Does it matter? No. Who cares? FA. So I'm going to calculate what FA is. Let's draw that down here. We have, there's my charge Q. There's my FA going like this. Do I want all of FA or do I want only a piece of FA? I want just the Y piece. So I need to break this into its components. I have a piece of this that's going down. We'll call that FAY. And a piece of this that's going over. FAX. Do I care about FAX? No. the 20. It's 21st century. We don't care about faxes. Ah. These are pretty good jokes considering I rode my bike in at 20 degrees at 6 o'clock this
I
morning.
didn't ask you about that. You wrote into that?
I did.
Yeah, mommy wrote.
My fingers are just now thawing.
You used to write in this.
Okay. So I need to figure out what FAY is. I can figure out what FA is, right? It's this. It's KQQ over R squared, which is K times charge A. What's charge A? 7.5 microcoulombs. 7.5 times 10 to the negative 6 coulombs times Q. What's Q? 2.
Oh, 2, yeah.
2 times 10 to the negative 6 coulombs. All over their separate. Oh, how far apart are these? The 10?
5.
Are they 5?
I think they're 5, right? Because those go halfway across the square.
I don't think they're 5 apart. I don't think they're 10 apart either. Let's see. Let's draw this picture again. Here's my QA. Here's my B, C, D. Here's my charge. I know that whole distance is 10. I want this distance. That's my R. So to get that, I need to go over and I need to go down. Each of these is 5. Going from the end of the square to the middle of the square, that gets me 5. Then I go from the middle down, that gets me another 5. That gets me, this is the hypotenuse of this triangle. So how do I find R? Pythagoras. R equals square root of 5 squared plus 5 squared. Square root of 50. What is the square root of 50? It's about 7.1. And that's 7.1 centimeters. What do I need it to be? Meters. How do I convert that to meters? Move the decimal to the left, 2 points. So R equals 0.07 meters. So then I can plug in for my R, 0.07 meters. That just gets me FA though. I want FAY. How do I find FAY from FA? What else do I need in this triangle? There's a couple things I could get. If I had FAX, then I have all 3 sides and I could figure out FAY. What else can I find? Angles. If I had this angle, then I could use, what trig function could I use if I had this angle? Sine or cosine. If I use this angle right here, is FAY adjacent or opposite to the theta? It's adjacent. So what would I use? Cosine. So cosine of theta is adjacent FAY over FA. So FAY is equal to FA times cosine of theta. I gotta get theta though. How do I get theta? What the heck is theta? Anybody know what theta is? 45. How'd you get that?
It's a 45, 45, 90 degree triangle.
How do you know that? Sides of the square that make this up are all the same. So since it's a square, each side is the same length. So if each side is the same length, then it is a 45, 45, 90 triangle. So that angle is 45 degrees. So FAY equals FA times cosine of 45. So FAY is going to be K times 7.5 times 10 to the negative 6 times 2 times 10 to the negative 6, all divided by 0.07 squared times cosine of 45. So you plug all of that into your calculator and you would get out your final answer. And what do you need to do to that final answer to get the total force? That's the force due to the A charge. How many other charges do we have? Multiply that by 4 because we have 3 other charges. So 4 total. I don't have a calculator, so I didn't calculate it. Somebody have a calculator? Plug in some numbers. This is always a fun thing, so everybody plug it into your calculators, and when you get an answer, shout it out. And we're going to see how many people get different answers plugging the exact same thing into your calculators.
It's K 8.99 times 10 to the 9.
Yeah.
What was it again, Teddy?
8.99 times 10 to the 9.
Are we just finding FAY?
Yeah, just find FAY.
Okay.
Find exactly what FAY is. So lots of you calculate it. We're going to take all of your answers and majority rules. Shout out your answer. Don't multiply by 4, just exactly what this gives.
19.45.
19.45?
Yeah, that's it.
If you're rounding.
Actually, it would be just 19.5.
19. 19's good.
Yeah.
19? Yeah?
Yeah.
19 what?
Newtons.
Newtons. Because it's a force.
Oh, right.
So what's F total?
76.
76 newtons because we multiply that by 4. Okay. Is that a problem that I would give on an exam? Possibly, yeah. Sure.
You know how to do it now.
Would I give you that exact problem?
Yes.
Absolutely not. What are things I could change about that problem? I could change distances. I could change signs of the charges, sizes of the charges. I could change the shape. I could give you a triangle. I could give you a rectangle. I could give you a trapezoid. I could give you a circle. All sorts of different things that I could change. Okay? That would make it trickier.
Unless it's just. I took that like, I don't even know how long ago. Freshman year. Yeah.
So this is one of the problems with physics. That problem, was that hard?
Super easy. It's varying in
What was hard about, was the physics in that problem hard?
No.
No, that was easy. Piece of cake. What
Getting
was
the
hard?
equation is the hard part. Deriving the equation is the hard part.
Knowing all the geometry.
Yeah. I
Right.
still don't know self-control. I
And-
never learned it.
I don't have time to teach you all of geometry, so that's why it's a prereq for the class. Yep, you come in here and you're expected to know sine, cosine, tangent,
Geometry.
all of those things. Yeah, I took it in 1992,
Well, I took it 12 years.
okay? So you're expected to know this trigonometry and practice with that. That's what made this one hard. Now this video, I will upload this up to YouTube. It'll pop up there, maybe, hopefully, as long as it doesn't get deleted. No guarantees that it will actually appear. It might get corrupted or something. Who knows? Okay. So never depend on the things that I record in class actually ending up on YouTube. And sometimes I'm going over problems and I curse while I'm going over problems, so YouTube flags them and then takes them down. So fuck YouTube. It's gonna get flagged.
You can put videos up as unlisted, and as long as you have a link, YouTube can't touch them, but everybody can see them.
I want everybody to see it. It should be okay. I have specifically listed my YouTube channel as not for children. So
NSF.
there we go.